Now we're down to our last topic from this polar graphing, and then we're going to talk about Archimedes Spiral. So again, from the textbook, the final polar equation we will discuss is the Archimedes Spiral, named for its discoverer, the Greek mathematician Archimedes. And if you have a chance, look him up. A lot of great, cool things. Circa 287 BC to circa 212 BC, who is credited with the numerous discoveries in the fields of geometry and mechanics. So Archimedes Spiral, the formula that generates the graph of Archimedes Spiral, is given by r equals theta, where theta is greater than 0. As theta increases, r increases at a constant rate in an ever-widening, never-ending spiraling path. So r equals theta from 0 to 2 pi. And if you keep on going to 4 pi, it keeps it going out. Of course, if you notice between these two, this was 2 pi. So this must be 6 here. So this must be 3. This must be, that's 6, 3. I guess this is 4 and this is 2. Where over here, they must have rescaled this, because if that's 4 pi, well, that's a little more than 12. So this is scaled differently. Like, I wonder if this is 10 here, for example. It's not clear. But anyway, the point is, it's Archimedes Spiral and keeps going out and getting bigger. My point is that these are not on the same scaling. So how to sketch the graph of Archimedes Spiral over 0 to 2 pi and make a table of values for r and theta over the given domain. Plot the points and sketch the graph. So we're going to go 0 to 2 pi. Well, let's make a table. So we can go theta. Where's my, there. Theta and r. 0, 0, pi over 6. Maybe it's good just to get the decimal approximation of that. So my calculator boots up. Pi divided by 6. 0.52. Then we'll do pi over 3. 1.04. So 1.05. Then pi over 2. 1.57. Then 2 pi over 3. We'll do 5 pi over 6. We'll do pi, which is 3.14. So 2 times, let's do that, gives me 2.09. And then 5 pi over 6, so I can say 5 times the pi over 6 one. Gives me 2.61. And we can do 7 pi over 6. 4 pi over 3. 3 pi over 2. 5 pi over 3. 11 pi over 6. And 2 pi. That's going to be about 6.28, excuse me, approximately. So 7 times the pi over 6. It's going to be 3.67. 4 times the pi over 3 gives me 4. I'm just going to say 4.2. And then 3 times the pi over 2, 4.7, and 5 times the pi over 3, getting 5.2, and then 11 times the pi over 6, and I'm getting 5.7. Let's say 5.8. Okay, so we'll start here. Then along this one, we're going to be at 0.52. So how should I scale this? Maybe call this 0.5 Well, we're going out 6.28, so maybe we'll call this 1, 2, 3, 4, 5, 6. So we start out here, then on this will be a 0.57, so right about there. Then we'll be at 1.5, so just right about there. Then we'll be at 1.57, so about there. And 2.3, so 2. Right about there. And then we're at 5 pi over 6, so we're going to be right about here. Then we'll be at 3.14, right about there. Then we're going to be at 3.67, 4.2, 4.7, 5.2, 5.8, and 6. So this is our spiral. Okay, I say that's the best graph I've done today. Okay, hope that makes sense. And we finished this section off. Yay.